everyone, and welcome to Amantya podcast series. We are back with yet another super interesting discussion. The topic of today's conversation is unleashing the next generation of networking with intent-based network. Intent-based networking is the future. It will revolutionize networking as we know it currently, taking it to an altogether different high. It creates networks that are more intuitive, automated, and aligned with business goals. So, what is intent-based networking? Why is it garnering so much interest? To answer these and more questions and to demystify intent-based networking, we have with us today our AVP Engineering, Indraneil Deb. Indraneil leads the engineering portfolio here at Amantya and is responsible for driving and growing the company's initiatives in the telecom domain. Welcome, Indraneil. Wonderful to have you here with us to talk about this exciting and upcoming new domain.
Nice to be here.
So, shall we get started?
By all means.
So my first question to you, Indraneil, is what is intent-based networking, and why is it garnering so much interest, and how is it different from the traditional networking approaches?
See, it is an interesting question. One of the main reasons why intent-based networks, came into the picture was the inordinate amount of time and resources that the network operators and even the customers of the network operators were spending managing networks. As time has evolved, networks have become infinitely more complex with multiple nodes, multiple applications and all kinds of other things that go into making up the modern network. Now, when you have to make any change on the network, you have to, an individual has to go and make changes at multiple places. So there are problems with competency because you need multiple people with multiple kind of competence, and you need a lot of manpower and a lot of resources. Intent-based networks are a new way of managing these networks. So intent, we need to understand what exactly is an intent in this context. Generally, an intent is a declarative statement, right? When you say I'm going to go somewhere, you are basically showing an intent. So an intent-based network essentially is a declarative statement that basically directs the network to attain and maintain a state, right? Now, attain and maintain are two keywords here, and there is absolutely no manual intervention involved. So when you make an intent, the network will translate that intent into configurations, parameters, or everything that it needs to configure down into the lower nodes and basically realize that intent. Okay. Make sure that the network functions as per the directive that you've given. So it cuts down a lot of downtime, it cuts down a lot of manual effort, and it basically allows you to turn around, makes the network respond to problems far more quicker than, a manual intervention would have. And that is why it is garnering so much interest these days. Because at the end of the day, when you deploy these networks, you're looking for high quality of experience for users so that user stickiness improves. And you're also looking for, let's say, as efficient operations as possible. So intent-based networking allows you to realize these kind of benefits.
Okay. So how are these typically implemented, and what are the key technologies or components involved in having an intent-based network up and running?
Now, the standard development organizations which are responsible for developing specifications that direct today's modern networks are also waking up to this fact, which is why Open RAN, which is a standard body that is doing a lot of groundbreaking work on the radio access network part of it, and the 3GPP, which is again one specification, a standard development body that essentially develops specifications for the entire telecom network as a whole. They have come up with two key nodes here. On the RAN side, we have what we call the RAN intelligent controller. Right now, the RAN intelligent controller is nothing but a system that picks up data that is generated from the RAN and processes it, derives intelligence out of it. When I say intelligence, it derives, it uses machine learning, AI and ML, to basically predict how the network could behave in the future based on previous data. Okay. And then it formulates that prediction into configurations, policies, KPIs, SLAs, etc., which is fed down into the network, right, and configured. So now you have you have a virtuous loop where data is generated, that data is analyzed. Based on that analysis, results are generated, and that result is fed down. So the network is self-correcting, self-configuring and self-correcting. The same concept is implemented on the core side by what we call the NWDAF, or the Network Data Analytics Function. It is a 3GPP node. The 3GP NWDAF is not a new concept. It was there in release 15 as well, but it did not gain a lot of traction because the data was not a lot of data was being generated. Relevant data was being generated by the network for the NWDAF to acquire any kind of significance. However, in release by the time we hit release 17, which was I think out in June 2022, a lot of important and interesting data are now being generated by telecom networks, which essentially means that the NWDAF has now gained prominence in terms of how it can be employed to implement the intent-based networks. And the third thing is the interface, the user interface part. Now, I have, for an intent-based networking system to be effective, I have to be able to provide that intent. Right. Now, I am just providing an intent in my natural language. How is that natural language, let's say, converted into something that the network can understand? Therein lies the most important trick, or the most important part behind implementing the IBNS. So three concepts: the RIC for the RAN, the NWDAF for the core, and then the entire intent engine that will translate your intent into configuration parameters or policies or what have you, so that the network can understand and function.
Mm-hmm. Wow, that's interesting. So, Indraneil, what kind of use cases and industries can benefit, most from this?
Right now, as if you talk about industries, my personal opinion is that it will impact all the industries where telecom networks are being used, because right now 5G is more of an horizontal, right? It impacts all industries, not just the telecom space. It impacts your industry, your industrial IoT. It impacts IoT. It impacts automotive. It impacts smart factories and what have you. It impacts everywhere. So similarly, going by that concept, the IBNS is well placed to make a significant impact across all of these industries, which is why based on certain projections, the intent-based market is expected to grow at a CAGR of about 25% to almost about 2.6 billion by 2027 from 0.8 billion in 2022. Yeah, so a CAGR of 25% across 5 years, which is significant. As far as the use cases are concerned, again, the use cases could be, for example, let's say you have and I'm going to explain this by an example, right? So the use case could be, let's say you have a RAN network, a radio access network, and you have certain load parameters that each RAN node is generating. That load parameter is fed back into the IBNS system, right? And based on that load parameter, the IBNS can actually predict which of the RAN nodes are going to have low load at a particular point in time. So the IBNS system can take proactive action and start to lower down power on those nodes at that point in time, and proactively switch users from this node to some other node. What does that mean? That means that you have significant power savings. So your RAN network is actually functioning at a power level which is most optimum for that time of day, and that can change based on the time of day. As soon as the time of day changes, the load increases, the power starts to go up, and you have normal functioning, and you have a normal functioning network. So power is one of the most is one of the biggest expenditures that MNOs sort of incur these days, right? That can help.
So these are the use cases and many more to come as we go along.
Yeah. This is an example. This is just an example.
Right. So what about migrating to internet, intent-based networks? How do organizations make it smooth, without hindering the existing networks and with, minimal downtime?
fundamentally speaking, there should be no downtime because we are not essentially changing anything that is fundamental to the telecom network, right? The only thing that you are doing is harnessing data and basically using an existing interface, an interface that the network already exposes to reconfigure the network. The only thing that changes is that the reconfiguration happens automatically and happens far more frequently, right? And far more effectively, right? It doesn't happen when a user actually sits on a configuration desk and then makes changes manually. It happens when the configuration is actually needed, not when the user is free to do that configuration. You get the difference, right? It is when the configuration is at its most dire need. That's when the network sends out an indication saying that, things are going wrong here. So, the network automatically reconfigures and recorrects itself. So the only thing that changes is that you have this new layer that comes and sits on top of the existing network that translates your intent and manages this self-correcting virtuous loop. At the end of the day, we continue to use whatever interfaces the network is has already exposed and whatever data the network is already generating. So fundamentally speaking, there should be no downtime and the switch should be very, very smooth.
And how do, organizations, how does these particular networks support, multi-vendor environments and, different networks and different devices?
As I said, the IBNS is network agnostic, so to speak, right? So it doesn't matter if you are serving if you're using multi-vendor devices or multi-vendor networks or multi-vendor components or multiple devices or what have you. The IBNS doesn't know, it doesn't care, right? It is just sitting on top of the network utilizing existing interfaces, right? And those interfaces are standard. Those interfaces are standard. They are well defined. They are defined by 3GPP. It doesn't matter which vendor you use. It doesn't matter which device you use. Those interfaces will have to be supported for a network node or a device to be compliant and available on any modern telecom network.
So basically, an exciting, evolutionary new thing, but
not evolutionary,
revolutionary. Yes, sorry, but at the same time, it's so simple.
Yes, so it's very simple. So here is the beauty, right? Imagine being able to talk to your network. You talk to Alexa, right? You talk to Alexa, you talk to your Google Assistant. Imagine being able to talk to your network. Just tell the network, look, network, I want so-and-so, this group of devices to be routed through this geography. That's all you say, and then the network does your bidding. That's where this entire thing is headed towards. It's not there yet, but that's the direction it's going to.
And coming to Amantya, specifically to Amantya, what is the company doing?
Thank you for asking that question because at Amantya, we're very excited about it, okay? This is a revolutionary concept, as we said. And in Amantya, we believe in investing in the future. And this, for us, is the future of telecom. That's where we see the industry going. We are building our own IBNS framework, all complete and we want it to be end-to-end. So we are not leaving anything out. We are working on building the NWDAP, the rake, and the intent engine. These are the three important components. We are working on some POCs with some of our customers. And in those POCs, we are also actually focusing on specific use cases where we are also developing AI/ML algorithms. One of the most important things, one of the most important ingredients in any complete IBNS system and also in the realization of a use case is the algorithm that will actually drive the IBNS, okay? And those algorithms typically can come from anywhere. Those are AI/ML algorithms and those can come from anywhere. So in these POCs that we are doing with our customers, with our partners, we are also building these algorithms. So very exciting times ahead for us.
Wow, that sounds like great times ahead. Absolutely. Yeah. Thank you so much, Indraneil. Very, very insightful session. Thank you for taking the time out and talking to us about this today. Thank you. Well, that's all for today, folks. Thank you for listening in. I hope the session was informative and useful for you all. We shall be back again with another interesting topic in discussion. Until then, this is Rohina signing off. Bye-bye.